Hey math enthusiast, I'm here to go over the notes for section 8.2, which deals with properties of parallelograms. So the first thing I want to think about is how exactly do I define a parallelogram? So it has to be a quadrilateral, which tells me it has to have four sides, and both pairs of opposite sides are going to be parallel. And we can see that in this picture off to the right. We have one single arrow on the left and the right side, and then two arrows on the top and the bottom. So if it is a parallelogram, then side PQ is going to be parallel to side SR, and QR is going to be parallel to PS. Which brings us to our first property. So if the quadrilateral is a parallelogram, then what's going to be true is that the opposite sides are going to be congruent. So we have one tick on QP and RS, and then two ticks on QR and PS. So if it is a parallelogram, then I know that RS is congruent to QP, and I know that QR is congruent to PS. So our next property states that if the quadrilateral is a parallelogram, then opposite angles are going to be congruent. So I can see that marked in my picture here. We can see that Q and S are congruent. They each have one arc, and angle P and angle R are congruent. They each have two arcs. So the figure is a parallelogram if angle P is congruent to angle R, and angle Q is congruent to angle S. Which brings us to our last property. So if the quadrilateral is a parallelogram, then adjacent angles are supplementary. So what that is saying is that in this parallelogram, if it is a parallelogram, x plus y is going to equal 180. So why exactly is that true? So let's say I have my parallel lines here. I have my one transversal here, so I'm essentially redrawing this piece of the parallelogram. X here, y is here. This angle pair that I've drawn out are actually consecutive interior angles. And we know from before, based on my properties of parallel angle pairs, that those two angles have to add up to 180. Which brings us to our first example. So for A, it looks like the left and the right side are parallel, and the top and the bottom of my figure are also parallel. So in this case, I know it is a parallelogram, which tells me that the opposite sides must be congruent. Well, in that case, I know that 2x minus 3 has to equal 37. In addition to that, the opposite angles in my parallelogram are congruent. So right away, I know that y has to equal 123. And the last property we discussed said that the adjacent angles have to add up to 180. So I know that z plus 123 equals 180. Now I should be able to go through and solve for x and z. So it looks like x is going to equal 20, y was 123, and z is 57. Now for example B, I'm actually going to add a couple markings on here. We'll say the left and the right side are parallel, and the top and the bottom are parallel. Now, in this case, all my variables deal with angles. All right, so we have h here, g here, and g here. Let's focus on the two angles that have the same variable. Well, it looks like they are adjacent angles inside a parallelogram. So therefore, the sum of these two angle measures should equal 180. So now that I have an equation set up to solve for g, I can go through and solve for that variable. Now once I've solved for g, I can go back to my picture and plug this value in. So it looks like down here I would have 3 times 21 plus 5, which gives me 68 for this lower angle. And then I would have 6 times 21 minus 14, which is going to give me 112. Now, the next thing I remember about my parallelograms is that the opposite angles, so this angle on the bottom left and this angle on the top right, are actually congruent. So therefore I know that the top right angle must also equal 68. So now I can set up another equation to help me solve for h. So I would have 9h minus 4 equals 68. Now I can go through and solve for the last variable. And it looks like h equals 8. Now for number 2, it looks like they're using that symbol for parallelogram. So I can sketch out a parallelogram down here. And I want to make sure I label it in this order. So E is right next to F. So I can either put F here or down here. All right, it doesn't matter where you put it as long as it's not in this third spot down here. F cannot be in that location. It has to be next to E. So we'll have E and F up top, then we'll put G down here, and lastly H. So all the vertices flow in that order: E, F, G, H. Okay, next thing they tell me is that according to my angle measures, angle G is 25 less than angle H. So let's start off and let's throw in some variables. Let's say that the measure of angle H is equal to x. Well, in that case, the measure of angle G, since it's 25 less than whatever H is, when we just said H is x, now I can label G as x minus 25. Now I have some measurements I can put in here. So I know H is x, and I know G is x minus 25. Now we could take it one step further and say, well, since it's a parallelogram, I know the opposite angles are going to be congruent, which means that angle F is also going to be x. And then that also means that angle E must be x minus 25. The next property I want to think about is those adjacent angles. So I know that any two angles in a parallelogram that are next to one another, that are adjacent, are going to add up to 180. So now I can set up an equation with these two, x and x minus 25, and set them equal to 180. Looks like I'm going to end up with 2x equals 205. And lastly, it looks like we're going to end up with a decimal, 102.5. The last thing they want is the measure for each interior angle. Well, obviously H and F, since they're both just x, are both going to be 102.5. The other ones are 25 less than that, so they're going to be 77.5. Which brings us to our last property of parallelograms. So a quadrilateral is considered to be a parallelogram if its diagonals bisect each other. And I can see that they've marked this in my picture. We have QM, which is congruent to MS, one tick there, and PM, which is congruent to RM, two ticks there. So it's going to be a parallelogram if this is true. QM congruent to SM, and PM congruent to RM. So for question number 3, we're given a parallelogram on our graph, VWXY, So that tells me that the left and the right side are parallel, and the top and the bottom are parallel. And they've drawn my diagonals for me. So these diagonals bisect each other, and where they intersect is at point Z. And it looks like Z is located at 3.5, 3. For example number 4, it's a little bit harder. I'm trying to solve for each of these variables. Let's add some markings to my picture. So we'll say the left and the right side are parallel, and the top and the bottom are parallel. So what that's going to tell me is that it is indeed a parallelogram, which means that these diagonals do bisect each other. So this point directly in the middle is the midpoint. So these two are congruent, as well as these two. So I'm trying to solve for V and T. Now let's focus on T first, since I have 3 expressions that involve T. So I'm going to focus on this segment, which is the 8t minus 30, and this segment, which is the 4t plus 6. So as we stated up above, these diagonals bisect each other. So I know that 8t minus 30 is going to be equal to 4t plus 6. Now I should be able to solve for t with this equation. So I found that t equals 9. The other thing I notice is that these two diagonals that are congruent, because they're bisected, are also going to be equal. So I can set up an equation with 2t plus 5 equals 9v minus 13. Now, in this case, I have an answer for t. So I can replace t with 9. And I can solve for the left side of the equation. It looks like I'm going to end up with 18 plus 5. So it looks like on the left side, I'm going to end up with 23. So now it should be a little bit easier to solve this equation because we only have one variable to deal with. So it looks like I'm going to end up with 36 equals 9v. And lastly, v equals 4. For question number 5, I'm told that MNOP is a parallelogram. But if it is a parallelogram, that means the opposite sides are congruent, like MP and NO. So what I want to do is show that that is actually true using the distance formula. So let's recall what that is. It's that large square root where I'm going to do x2 minus x1 squared plus y2 minus y1 squared. So let's focus on MP first. So I'm trying to find the distance from M to P. So we have M here and I have P here. We'll use P as our x2, y2. So they're going to be my first coordinates that I'm plugging into each set of parentheses. So it looks like we're going to have 3 minus negative 5 squared. Then the second set, I'm going to have 7 minus negative 1 squared. So it looks like when I go through and simplify what's in my parentheses, I'm going to end up with 8 squared plus 8 squared. Then I'm going to end up with 64 plus 64, which gives me 128. The last thing you can do, even though they didn't specifically ask for it, is simplify this radical. 128 can be broken down into radical 64 times radical 2. Radical 64, the square root of 64, just becomes 8. Square root of 2, I can't simplify that anymore, so it just remains square root of 2. Okay, now let's move on and take a look at NO. So I'm trying to find the distance from N to O. Let's highlight these points, N and O. We'll use O as our x2, y2. So in my set of parentheses, we're going to have 3 minus negative 5 squared. And we have 3 minus negative 5 squared again. So both set of parentheses are the same. It looks like I'm going to end up with positive 8 squared, positive 8 squared, which is going to give me 64 plus 64. This should look familiar, which then gives me square root of 128, which will lead to 8 radical 2. So now I've shown that according to the distance formula, MP is congruent to NO. For the last problem in our notes, they give us 3 vertices of parallelogram GHIJ. And I'm looking for the coordinates of I. So first let's start off and graph these points. Let's also include some labels on our graph. So I know that this is G at the origin, H is at 2, 3, J is at 6, 1. Now I know that G will connect to H. I also know that G also connects with J, since that's the first and last points listed. So now I can kind of get an idea as to where I is going to fall. I connects to H, I also connects to J. So it looks like it's going to be somewhere in this vicinity. Okay, so how am I going to find this? Several different ways. So let's think about our definition of a parallelogram. My definition tells me opposite sides are parallel. Okay, so what I would have to do in this case is make sure that opposite sides are going to be parallel. So the left side is parallel with the right, and the bottom is parallel with the top. Well, in order to make sure they're parallel, I'm going to need some slopes. So first, let's find the slope of GH. So you're welcome to use the graph. We can use the slope formula if we want. 3 minus 0, 2 minus 0. Looks like my slope is positive 3 over 2. The other slope I want to find is the slope of GJ. Once again, I can use the formula or the graph. Doesn't make a difference. Looks like I'm going to have 1 minus 0 and 6 minus 0, which gives me a slope of positive 1 to 6. So what I'm going to do with this information is then continue to draw my lines so that they are parallel. So I'm going to start at point J, and I'm going to use the first slope I found for GH. So I want to make sure it's parallel to that. So I'm going to go up 3 and right 2. So I'm going up 3 units, right 2 units to this point right here. So I want to erase what I drew on here. So this is the point I'm worried about, and this should be the location of point I. So now if I connect this, I should have the same slope. The other way we can do it is focusing on the other slope, GJ. So now I'm going to start at point H, and I'm going to use that same slope, 1 to 6. So I'm going to rise 1, and I'm going to run 6, and I should end up hitting that point where I graphed I. So this should be the other side of my parallelogram. So I'm done. I found the location of I using my definition of a parallelogram, showing that opposite sides are congruent. Now, the other option for solving this problem would be to focus on the fact that in a parallelogram, opposite sides are not only parallel, but the opposite sides are congruent. So now in this case, I would have to figure out what is the length of GH using the distance formula. and what is the length of GJ using the distance formula? So I can plug in my coordinates. Looks like I would have 2 minus 0 squared plus 3 minus 0 squared. Looks like I'm going to get 2 squared plus 3 squared, which is going to give me 4 and 9, which gives me radical 13. Next one, for GJ, we're going to have 6 minus 0 squared plus 1 minus 0 squared. Next, it looks like I'm going to end up with 6 squared. I'm going to end up with 1 squared, which is going to leave me with 36 plus 1, which leaves me with radical 37. Okay, so how exactly does this help me? So what I need to do is make sure I select a point I so that my other sides have the same length. So I want to make sure JI has a length of radical 13, and I want to make sure HI has a length of radical 37. So for something like this, I am going to have to rely on the graph. So let's think about these coordinates that I got right here. So if I were to sketch out a right triangle for GH, what I'm going to notice is that I have a right triangle with side lengths 2 and 3. And that led me to these values in this step and led me to my length of radical 13. I'm going to do the same from point J. I want to sketch out a right triangle, height of 3, base of 2, and that's going to lead me to my new point. So that's where point I should be located. Now, the other option is to focus on GJ. So for GJ, in this step, my two lengths were 6 and 1. And I can see that here on the graph with my right triangle with a base of 6 and a height of 1. Well, HI has to have the same length, that radical 37. So starting from point H, I'm going to draw a right triangle with a base 6 and a height 1. And that's going to give me the same length. That's going to give me that radical 37 as well. So in this case, I've shown the location of point I by stating that the opposite sides must be congruent. Now, on the graph, it's tough to use the properties about the angles, opposite angles being congruent and adjacent angles being supplementary. But it is possible to use the fact that the diagonals bisect each other. But that one's definitely your hardest option. So I would say first stick with the fact of trying to show that the opposite sides are parallel. If that's not working for you, then you can move on to this method, which is obviously a little more detailed. Now, both of these methods also help if you are given a quadrilateral and have to prove that it is a parallelogram. So you can do that by showing the opposite sides are parallel or showing that the opposite sides are congruent.